Okay. Okay, guys. This problem. Oops. This problem was released in 2006. It's no calculator allowed. It's one of those problems we have to solve doing derivatives and integrations. Okay. So the problem says it's a twice differentiable function is defined for all real numbers and satisfies the next condition. So we have f of x differentiable on all real numbers. And then the conditions are f of 0 equals 2, f prime of 0 equals -4, and f double prime in 0 equals 3. So those are the information we have. Correct? Then we have the first question. This the function g is given by g of x is defined as e to the ax plus f of x. So it's the combination of this function we don't know and the exponential. For all real numbers, when a is a constant. Constant, right? And it's on the reals, correct? We have to find g prime of 0 and g double prime in 0 also, in terms of a. Okay? It's a show work, that's important. So let me just go back here. Okay, let me see. I didn't share. Okay, here is. I just writing everything. So this is the problem, right? This is the twice differentiable function. F is defined for all real numbers and satisfies the following conditions. F of 0 equals 2, f prime of 0 equals 4, f double prime 0, 3. And then they define a function, g of x, in these terms, and then they want g prime in 0 and g double prime in 0. So, okay. So, this is not a problem. So what you can do very simply is, okay, I'm going to take my calculus, right? So g prime of x is the derivative respect x of e to the ax plus f of x, correct? Now this is derivative of the exponential is the exponential again, times a, the derivative of this one, plus f prime of x. Then if you want g prime of 0, the only you have to do is put a 0, e to the a times 0 times a plus f prime of 0. Then you see, okay, e to the 0 is 1, so this is a plus f prime of 0 is 4, or my -4, so plus -4. So my answer is a minus 4. That is the first answer, correct? Again, not big calculations, so just values you receive, a definition you have, and the fact that the derivative of an addition is the addition of the corresponding derivatives. So you operate these ones as you know, the exponential and f prime, and then you plug in the values. The exponential of 0 is 1, me queda a, and I have f prime of 0 that is -4, so everything is a minus 4. The same is going to happen for g double prime. G double prime of x is the derivative respect x of the second derivative, so this one. So e to the ax plus f prime of x, right? And again, you use the properties, so derivative of this is e to the ax, derivative of this is a times a is a squared, plus f double prime of x. And then you see easily what is going to be my answer. G double prime of 0 is a squared e to the a times 0 plus f double prime in 0. And then what? Well, this is 1 times a squared, and f double prime of 0 is 3. That's the answer. Okay, important. Without this work, you are not going to get any point. Even if you mentally do the thing and get these two right here, these two answers, and they are correct, remember that there are no points only for the correct answer. You need to show work. Okay, so no, it's not difficult, but it's pretty much what you have to do. You want credit, okay, for this problem. Okay, questions here? It's pretty simple. Let me just now go to the second part. In the second part, you read, the function h is given by another composition. Let me just write it here. I'm going to write here the function, right? So it's h of x. Oh, h of x is cosine of kx times fx. So that's the way the function is defined. hx is cosine of kx times fx. For all real numbers again, this is on all real numbers. K is a constant. And find h prime. We have to find h prime of x, right? And write the equation for the line tangent to the graph at h at x equals 0. It's an equation of tangent for x equals 0, correct? Okay, well, not a big deal. We have to do exactly the same as we did. So we need h prime. Okay. H prime of x is the derivative respect x of cosine of kx, f of x. And then I have to use the properties of derivative. This is a product, so it's going to be derivative of the first one, negative sign, kx. Derivative of the kx is k times fx, plus this one times derivative of the second one. So it's going to be cosine kx times f prime of x, correct? Okay, well, now I need to get the equation of the tangent line in x equals 0. So again, I have to remember my algebra 1. The equation of a line is going to be always given in this form. Y minus y0 equals mx equals 0. Now I have to identify who's who. So x0 is 0. Y0 is h of 0, correct? Because this is the y equals a function of x, right? So it's h0, and the slope is h prime in 0, is the slope of the tangent line in 0, correct? So my algebra is always the same. So what I have to do is identify what is here in my basic algebra with what I have here from my calculus. So I did it already. X0 is 0, Y0 is h of 0, and M is the slope of the tangent line in 0. That's given by h prime. Okay. Well, let's do the things. So let's just find only h of 0 is, I'm going to put here, cosine, according with this, is this evaluated in 0, cosine of 0 times f of 0. And I have to remember that f of 0 is 2, and cosine of 0 is 1. Don't forget that. So h of 0 is 2. Correct? Now I need h prime in 0. Okay, so I have to evaluate this thing in 0. Okay, sine of 0 is 0. Remember that. So it's 0 plus cosine of k times 0 times f prime in 0. So this is 1, and this is negative 4. So this is negative 4, correct? So once you have this, not a big deal, you write your equation. So you have y minus y0, but y0 is 2 equals a slope, negative 4, parenthesis x minus 0. And that's my answer. Okay? I hope you have noticed that pretty much the questions are repetitive. You have to compute a lot of equations of tangent lines. Okay? Remember we did that one in other problems. Yeah, in the free responses, or maybe multiple choices. This is common. So there is no excuse that you miss one of these problems. Because from the equation of the line that usually is this one, a slope with a point, because you receive a point, and then you have a slope, that is the derivative, then you identify the terms, and then you have your equation. Obviously, the calculus to determine the derivative, and that's it. Okay? Questions? Complaints? No? Rangel? Piece of cake?
No sé.
You should, man.
Cake, no.
You are 3 weeks away from the big day. A ver, this is data. No problem, correct?
Yeah.
Then you define a function like this. Well, it's a function. Then you need h prime. Any problem with that? The derivative of this is this.
No.
You need the equation of the tangent line in 0. Okay. This is the point x, 0. So you know this one. Then you know that this is the y. This is the y. This is y is a function of x. So this is the y. Okay. Y equals h in 0. And then the slope is h prime in 0. The slope of the tangent line in the point, 0. Then you evaluate what you get. You evaluate this function in 0. You evaluate this function in 0. You get then the points you have to, and then you just substitute. So what is the problem? Be careful. You have to be concentrated, focused. Yeah. You may have something as simple as this. I don't know what you're going to receive, but you're going to have something simple like this. Okay. Bueno, let's move on to the next question, or next problem. Let me just check here. This is the one we solved. It's just questions. This is not common. Usually you have 3 or 4, like this one, right? This is, man. Again, you have a graph, height versus distance, I guess, x. And you have 4 questions to answer given this information, okay? So, this is the figure above is the graph of a function of x, okay? Which models the height of a skateboard ramp. The function meets the following requirements. At x equals 0, the value of the function is 0, is what we see here, correct? And the slope of the graph of the function is 1. Oh, no, here, this is, and the slope of the graph of the function is 0 in x equals 0. At x equals 4, the value of the function is 1, okay? Well, I don't know where is the 4, but right somewhere here is the 4. And the slope of the graph of the function is 1. Okay, let me just write that information. So it's what I'm going to do in my board. So I have this, I have h of x, right? And it's differentiable. Okay, now I have that h of 0 is 0. So I'm going to write that one right here. So h of x is a differentiable function. H of 0 is 0. And h prime in 0 is 0. So it's a horizontal slope. Then I have that h of 4 is 1. That x equals 4 is 1. And h prime in 4, oops. H prime in 4 is 1, correct? Okay, that's the information I read in sections I and 2, right? Okay, the next portion is this one. So between x0 and x equals 4, the function is increasing. Okay. So what do you mean the function is increasing? This is h prime of x positive on 0, 4. So those are the hypotheses we have. Let me just put this one a little bit to the right. This is h prime of x positive on 0, 1. No, 0, 4. Okay. Okie dokie. So this is the information we have. Now we have to answer questions with this information. So first question is let f of x equals ax squared, where a is a non-zero constant, show that it's not possible to find a value for a so that f meet the requirements above. Okay. Okay, let's see. So I have here, let me just put here my line and return to my board. Yep. So this is f of x is a x squared. Okay. So a is a non-zero constant. So a is different than 0. It's a show that it's not possible to find a value for a so that f meets the requirements I above. Okay. Let's see. Okay, I put h, but it's going to be the same. So h, let me just put f's here. F, 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 and F, and F. That's it. So much better. Okay. Well, let's see. Remember that my function is 0 is 0. So f of 0 is 0. So this is going to be a times 0 squared is 0. So a could be any number. Then f prime of 0, a prime of 0 is 0. So this is 2ax, right? 2a in 0, because the derivative of this is 2ax. And this is 0, so a could be any a. So in this case, the first condition don't give me anything. But let's see the second condition. F in 4 is 1. Okay. So I have that, well, this is going to be equals a times 4 squared. And this has to be 1, correct? So because a is ax squared, I put a 4, and it has to be 1. So a is 1 over 16, correct? Now you determine the a, so you have f of x equals x squared over 16. So we have the constant. Now let's see f prime, because the condition here is f prime in 4 is 1. So f prime of x is 2x over 16. The derivative of x squared is 2x over 16. So you have x over 8, right? And now we know that f prime of 4 is 1. And this means that f prime of 4 is 4 over 8. And what is the problem? According with my function, this is 1/2. So this and this are different. So not possible. Correct? Right here. So not possible. So this is f of x is x squared over 16. Then f prime of x is derivative of x squared is 2x over 16, x over 8. And then I have f prime of 4 equals 1. That's my condition here, right? So from here, right here. And well, according with the function I found before, f prime of 4 is 4/8 as 1/2. So not possible. Okay. So really, this this portion here is something that you may skip. You may focus right here in the 4, and f of 4 equals 1, and then you determine the a, and then with that a you determine the derivative, and then you determine the derivative in 4, and you see that is 1/2 is not matching your condition. Okay, so this cannot be the function. Okay. Questions at this point? Everybody understood how I got the a? So I just set a condition, and with this condition, I set the value of a, forcing f of 4 equals 1. Then with that value, I determine the derivative, and I see that this is impossible. Okay. Let's see the next question. Right here. Let g of x now a cubic function, c of x cubed, cx cubed minus x squared over 16, where c is a non-zero constant. Find the value of c so that g meets requirement 2 above. Show the word that leads to your answer. Okay, let's see. So you have again your function. So g of x is g of x is cx cubed minus x squared over 16, right? So that's the new function, okay? Now, we have to find the same solution, right? So I'm going to take g of x, g of 4, let me see, g of 4, I do this one. Okay, let me just do g prime of x. Let's just try a prime directly. So this is 3c x squared, derivative of this is this one, minus derivative of this is 2x, so it's x over 8, correct? So I have 3c squared, x squared, the derivative of this, minus the derivative of this. Now I want the condition. The condition is g prime of 4 is 1. Okay, let's see. So I have to put here a 4 and make it equals 1. So 3 times 4 times 1, no, 3z times 1 squared minus 1 over 8 equals 1. Okay, so let's see what happened in this point. Okay, you move this to the other side, so you have 3c equals 1 minus 1, 8. So this is 7/8, right? And you divide by 3, you get z equals 7 over 24. Okay, looks cool. Let's see. With this one, we force g of prime of 4 is 7 over 24. Okay. Okay, any question here? No? Pretty easy. Okay. No questions? Good. Okay, David Rangel se salió. Okay, David. What's up, David?
Ya regresé.
Okay, here we. Okay, this was the point. So now you have this function, and then you want that meets this condition, correct? f prime of 4 equals 1. So, okay, you have g prime of 4 equals 1. So you get the derivative of this function, and then you substitute the 1, and then you solve equals 1. You find the value of c, you get c is 7 over 24. So this function is going to be, right? With 7 over c equals 24, you meet the condition, this one. I have a question. Do you think it's going to be g of 4 equals 1 also? Let me just try to check, because sometimes there is it. G of 4 is 7 over 24 times, no, g of 4 is 1, 4 squared, minus 4 squared over 16. So I'm just going to evaluate this in 4, and this is cube. This in 4, this in 4, and then I'm going to check if this is going to give me a 1. I don't know, I just have this question. So this is going to be 7 times 4 times 4 times 4 over 24. Remember, there is no calculator here. 16 over 16, correct? Okay, this is a 1. Here, I have, let me just reduce this one. 3 times 4 times 2, correct? I cancel a 4. I divide by 2. And then I have 56 over 3. No. Sí. Son, no. 7% 49, 7%. That's the point. Minus 16 over 16. And I don't see this equals 1. Well, I don't know. But the condition is this one. So this is what we have to do. I don't know why. Let me just explain you what happened here, really. So you have a condition. The derivative has to be 1. So I set with this condition. But when I wanted to do this one, g of 4 equals 1, this condition, I see that it's not matching. And technically, this should match both conditions. What's the problem here? Okay, let me just stop right here the record again. So what we did is this, f of 4 is 1, f prime of 4 is 1. So this has to be the conditions this function has to meet. So g prime of 4 is 1, g prime of 4 is 1. So I put this equation, I put the 4 equals 1. I solve for c, I get c equals 132. Then I put the 32 right here in the original equation. I get g prime, this is g prime. And then I put 4. Put a 4 here. And then I check that this g prime of 4 is 1. Okay. It's a long thing, right? Questions at this point? Sorry about the previous explanation. We have to begin really with the first equation. Okay, let's do the next one. Right? So right here, this is using the function g and your value of c from part B, show that g does not meet requirements 3 above. Okay, vamos a ver. Between 0 and 4, the function is increasing. Okay, let's see. So we have, let me just put this one. G of x is x cubed over 32 plus x squared over 16. Okay. Okay, right here. This is the function we got. X cubed over 32 plus x squared over 16. Now, We have to show the second part. This is I, 2 i's, and 3 i's, correct? So g prime of x positive on 0, 4. So that's the question. Okay, let's see. G prime of x again, 3x squared over 32 plus x over 8. Now, how's this thing? Let me see. That's minus. Oh, this is minus, sorry. This is minus, and this is minus. Correct? So let me just do a factoring. So I have x over 8, parentheses, 3x over 4 minus 1. Okay? Let me just multiply. 8 times 4, 32. X times x, 3x squared. X times x over 8 times 1, this one. Now, here is the point. How's this graph between 0 and 4? Okay. This, let me just put it right here. G prime of x equals x over 8, 3x over 4 minus 1, correct? So, x over 8 is positive on 0, 4. That's not difficult to check because the x is more than 0 and is less than 4. This is always positive. Positive over a positive is positive. But 3x over 4 minus 1, right, is positive only for what values? It's okay. For x's greater than 4/3. Everybody's understand what happened from here to here? I just add 1, multiply times 4, and divide by 3. So for x less than 3/4, 3x over 4 minus 1 is negative. So this is what we check. So the question was prove that g prime of x is not completely positive or increasing on x equals 4. So it's increasing while the derivative is positive. So it's increasing after 3/4, but it's decreasing before 4/3, I mean, 4/3. Correct? A ver, David, what kind of point is this one? Is decreasing before 4/3, right? And is increasing after 4/3. What point is that? You have
Increasing before.
now what kind of point? So the function is this or is this?
Oh. The first one? The U?
So is negative before, right? And positive. Yeah, this is a mean. Correct?
Mm-hmm.
So the model, this function models something like that. So well, could be a scooter thing, yeah, or skate thing, but not necessarily as we have in the previous function, in the graphing. Everybody catch this idea? Well, last question. So okay, let me see this one. This is this last question. H equals x to the n k, where k is a non-zero constant, n is a positive integer. Find the values k and n so that h meets requirements 2 above. So show that h also meets requirements 1 and 3. This is, oh my God. Yep. So I have, stop sharing. I have now h of x equals x of n over k, right? Two constants and positives, correct? Now, we have to meet the three conditions. So this says, find the values k and n so that h meets requirements 2. These ones, right? It's okay, let's see. I need that h of 4 is 1, h of prime of 4 is 1. So those are the conditions. So, okay, let's do the first condition. The first condition is 4 to the n over k is 1, and the derivative is n, right, times 4 to the n minus 1 over k is 1. So h prime, remember, I did the derivative mentally, but it's n x n minus 1 over k. So that's the derivative. So what I'm doing is h of 4 is 1, so I put a 4 right here. 4 to the n over k is 1. And then I have the derivative. So I have this is the derivative, so I evaluate in 4. It says n 4 to the n minus 1, k equals 1. Correct? Okie dokie, well, okay, guys. A ver, Sergio. Digo, Sergio. Brandon. Sergio está en Atlanta. Okay. Can you solve this? Because you have this equation, and then you have this equation. So you have one variable here, and then you have this one. So can you solve?
Yes.
Yeah.
Okay. Step number 1, what you do?
You plug in for n or h, I mean.
Well, I have this equation, so I have these two, correct? I know this is 1 and this is 1, correct? So these two are the same, correct? A ver, everybody catch the reasoning?
Yep.
If this quotient is 1 and this quotient is 1, so these two quotients have to be equals. So I have to do this. 4 to the n over k equals n 4 to the n minus 1 over k.
Entonces n va a ser 1.
Posiblemente. Let's see. You can cancel out this one. K is different than 0, so I can multiply everything times k. So I have 4n equals n 4n minus 1, correct? Now, 4n is 4n minus 1 times 4 equals n equals 4, no, n times 4n minus 1. But everybody catch what happened here? This one? To this one? Everybody understood what happened here?
No.
No.
Yeah, no.
Come on, it's algebra 1. 4 to the n is 4 to the n minus 1 times 4. What is this product? It says 4 to the n minus 1 times 4 is, this is 4 to the 1. This is 4, the same base, n minus 1 plus 1. And that is
okay. Yeah.
Wait, what?
Yeah.
Ver, 4 to the n minus 1 times 4 to the 1, this is 4 to the 1, correct?
Yeah.
Is 4 to the n minus 1 plus 1. When you have two exponents with the same base, you add the power.
Add them. Yeah.
And what is that?
Same thing, 4 to the n.
4 to the n. Okay. What you can do with these 4 to the n's right here, minus 1s?
Cancel out.
Correct, you cancel out. And you have n equals 4.
Wow.
Correct? So n cannot be 1. Okay, now I have a value of n, so I can use any of these two equations to find the k. Which one you want to use? You know now the n is 4.
The first one.
The first one. So 4 to the 4 over k is 1, correct?
4 times 16, 64.
Let's go to the k.
256. 256?
Correct. 256. So what is the function I found? Well, my function, after all this thing, my function h is x to the 4 over 256, correct? So this is the function. Now what you have to do? You have to check that this function satisfies that f of 0 is 0 and f prime of 0 is 0, and that f prime is always positive between 0 and 2, and 0 and 4. Okay? So let me just finish with that. So I'm going to use this portion of the board. So I'm going to put right here, right? So I have h of x equals x to the 4 over 256. So h of 0 equals 0 and h prime of 0 equals 0. That happens, okay. How much is h of 0? H of 0 is 0 to the 4 over 256, so that's 0, correct. H prime of x, what is that? Well, get the derivative of this. 4x cubed over 256. How much is h prime of 0? Well, it's 4 times 0 cubed over 256. That's 0, correct. Now, is h prime of x positive on 0, 4? Okay, let's see. 4x cubed over 256 positive. What do you think? A ver, Areli. Is positive that expression for any value between 0 and 4?
Yeah.
No, it's
A ver, chéquenlo bien. A ver, si tú pones un 1, Rangel, and you put here a 1, what you get? A positive or a negative?
positive,
If you put a 2,
positive.
if you put a 3,
Oh, so it's positive?
well, you should be able to do this, man. You are graduating this year.
Yeah, I thought you meant like the curve.
Well, this is a curve. It's a cubic, right?
Yeah.
And this is a 4 power. So both are increasing. So this is the derivative of this. So this is always positive between 0 and 4. So this is always increasing, correct? This is yes.
Hey, Ramirez, I have to go.
Ándale pues.
See you
Go ahead.
tomorrow. Thanks.
See you tomorrow at the same time.
Yes, sir.
Okay.
Bye.
Bueno. Everybody else, any question here about this problem, this crazy problem? No? Samurios?
Saborio está muerto.
No, I got everything except for the very last part, like that all black. I was gonna start getting confused a little bit, but I think
A ver,
now
vamos
that
a
I
ver.
look at it, I think I'm fine.
A ver, right here. This is the function we got, correct? K equals 256 and 4. So this function is this one, right?
Yeah.
And the only you have to do is evaluate in 0 because that's the condition. This is the condition. The function in 0 is 0. The derivative in 0 is 0. Okay. H on 0. You put a 0 here, what you get?
0.
0. Correct. You get the derivative. 256 is always a constant, so you put it at the bottom. What is the derivative of x4? 4x cubed.
4x cubed. Yeah.
Now you put a 0, what you get?
0.
Okay. Now, this is the derivative. This is the derivative. The derivative is positive always in 0, 4. Is this expression positive for all those points?
Yeah. Yes.
The
It
cube
is, right?
of a positive is positive, correct, Tom? All these are positives. So yes. So this function fulfills the 3 conditions. We determine n and k from these 2, and then we check that the function fulfills the other 2. It's the only thing. Okay?
Okay.
Okay, guys. Tomorrow we're going to do more problems. Remember, you have